Hello and welcome to our third video on the ideal gas law for atmospheric thermodynamics. And we discussed ideal gases and what is an ideal gas, what are the assumptions, what is not an ideal gas. We've also discussed the different relationships that were discovered between pressure, temperature, and volume of a gas. Those were called Boyle's law and also Charles's law or Gay-Lussac's law. Now we're going to work our way into our atmosphere and talk about how the ideal gas law interacts or how it works in our atmosphere. So when we discussed the kinetic theory of gases, we looked at the story of a molecule named point mass. And we said that point mass had many other molecules just like him. In other words, we're talking about a gas that was made up of only one element. In other words, the molecules were all the same. And that's not necessarily true. Sometimes we do have gases that are a mixture. What we've been discussing with the ideal gas law is a gas that is made up of only one element. But you know, our atmosphere is made up of a mixture of gases, so not all the molecules are identical. They're not all point mass. They are made of different elements. And we have to look at the ideal gas law and account for that. As you know, in our atmosphere, the major constituents are oxygen, nitrogen, and argon in certain percentages per volume. And then there are trace gases in our atmosphere. And the trace gases are carbon dioxide, neon, helium, krypton, hydrogen, xenon, ozone, water vapor, also methane. Some of these gases are very important gases because they're greenhouse gases and they affect the absorption of infrared radiation within our atmosphere. Back at the turn of the 18th century, actually it was the 19th century, John Dalton came up with a concept, and he's considered the father of modern chemistry. And his idea was called Dalton's law, and he theorized that the pressure that's exerted by a mixture of gases is the sum of the pressure of each gas as if it occupied the volume alone. So, in other words, the total pressure of a gas is the sum of the partial pressures. So in our atmosphere, we have approximately at sea level about 1,000 millibars of pressure that's exerted by our atmosphere. But since oxygen is 21% of the atmosphere, it's probably exerting about 210 millibars of pressure. Nitrogen, 78% of the atmosphere, is exerting about 780 millibars of pressure, and argon, which is 1%, is probably exerting about 10 millibars of pressure. So that's how we deal with a mixture of gases, such as our atmosphere. That's kind of an overview. What we're going to do now is spend a little bit more time looking at this mathematically and try and come up with a way that we can handle this with the ideal gas law. So come back and watch the next video.